There are animals that came from different universes. These are the untouchables. NASA, known for its essential disclosures, has affirmed that this new planet isn't simply captivating because of its size and area, but in addition since it shows lights that give off an impression of being fake. Are we uncovering stowed-away bits of insight that could change how we might interpret the universe? Might this revelation at any point highlight life on different planets? Join us as we explore NASA's thrilling discoveries and uncover the truth behind these baffling lights. In 2007, NASA sent off the Dawn space apparatus with a mission to concentrate on the most intriguing objects within our nearby planet group. Dawn was furnished with 3 ion motors, allowing it to set out on an exceptional journey. The shuttle's mission started with a 14-month examination of Vesta, the second-largest space rock in the belt. During this time, Dawn sent back detailed pictures and information, uncovering Vesta's complex surface and various land features. After completing its first objective, Vesta, Dawn set its sights on the dwarf planet Ceres. Thanks to its ion motors, Dawn could leave Vesta's orbit and travel to Ceres, an endeavor that traditional chemical propulsion would have struggled with. The ion motors provided a gentle, continuous push, allowing Dawn to travel vast distances and enter a stable orbit around Ceres. Discovered in 1801 by Italian astronomer Giuseppe Piazzi, Ceres is the largest object in the asteroid belt between Mars and Jupiter. For years, it was considered the smallest dwarf planet in our solar system until its renaming in 2006. With a diameter of around 950 kilometers, Ceres is not only the largest body in the asteroid belt but also one of the most captivating due to its unique characteristics. As Dawn approached Ceres, scientists eagerly awaited the first clear images of the mysterious world. They saw bright spots scattered across its surface, particularly in a large crater, sparking excitement and speculation among researchers. Before Dawn's mission, the best image we had of Ceres was a blurry, low-resolution photograph taken by the Hubble Space Telescope. Scientists knew little about this dwarf planet, and the chance to examine it closely was exhilarating. What mysteries would Ceres reveal? What new discoveries awaited? Dawn was expected to provide valuable insights into the formation of our solar system and the role of water in shaping planetary bodies. The bright spots on Ceres were unlike anything seen on other asteroids. They appeared to be made of highly reflective materials, possibly salts left behind by evaporated water. This raised the possibility of cryovolcanism on Ceres, a process where volcanoes emit water or briny fluids instead of molten rock. But what exactly are these strange lights, and what do they tell us about Ceres? Might they be signs of ongoing geological activity, or something even more extraordinary? Ceres stands out from other bodies in the asteroid belt due to its size, mass, composition, and potential for water and ice. Unlike most rocky asteroids, Ceres is more like a comet, suggesting it holds more clues about the early solar system than we ever imagined. After 2 years of travel, the Dawn spacecraft finally began its approach to Ceres in mid-2015. This was a significant achievement, as Dawn sent back humanity's first close-up pictures of the massive object in the asteroid belt. As Dawn drew nearer, the photos of Ceres became clearer, offering us our first detailed views of a previously mysterious world. The first images showed a surface dotted with craters, indicating a long history of impacts. But it wasn't the craters that drew attention. Among these features were surprising bright spots contrasting with the darker, rough terrain. As the photos improved in resolution, scientists speculated about the nature of these spots. Were they patches of ice reflecting sunlight, or could they be something even more intriguing? Some thought they might be mineral deposits or signs of cryovolcanic activity. Closer inspection revealed that the brightest spot was not a single feature, but perhaps a combination of several distinct regions. This discovery deepened the mystery, suggesting that these might be salt deposits from evaporated water. If so, this would imply that Ceres once had, or still has, some form of geological activity that moves water or briny fluids to the surface, where they quickly evaporate, leaving reflective deposits behind. These findings challenged previous theories about Ceres, showing it to be a more dynamic and complex world than previously thought. The presence of such features hinted at the possibility of subsurface water or briny pockets, which could have profound implications for the potential for life in our solar system. What makes Ceres so significant compared to other planets? Ceres is often described as a cold planet with a harsh but gentle surface. Unlike most asteroids in the belt, which are composed primarily of rock and metal, Ceres stands out due to its unique composition. Its surface is a mixture of water, ice, and hydrated minerals like clays and carbonates, making it less dense than its neighbors. This suggests that Ceres contains a substantial amount of water. Its surface is rough but porous, with ice and other substances trapped within. This chilly nature is more akin to that of a comet than a typical asteroid, highlighting a history that may have involved both rocky and icy materials. Digging further beneath its surface, Ceres reveals even more fascinating aspects of its structure. The dwarf planet is believed to have a layered interior, with a slushy mantle and a core. The mantle is thought to be rich in water ice, making up about half of Ceres' total volume. This icy layer, possibly mixed with rock and briny water, surrounds a denser core, potentially made of silicates. The vast amount of water ice suggests that Ceres may have once had liquid water, particularly if its core was heated by radioactive decay early on. This structure sets Ceres apart from other asteroids and raises intriguing questions about its potential for geological activity and the role of water in its evolution. Furthermore, the discovery of ammonia clays on Ceres suggests that it could have formed in a cooler, older part of the solar system before migrating inward. The presence of ammonia lowers the freezing point of water, supporting the idea of subsurface briny water. These findings enhance our understanding of Ceres and offer key insights into the formation and evolution of icy bodies in the solar system. Cryovolcanism is a fascinating geological process, quite different from the volcanoes we see on Earth. While customary volcanoes emit liquid stone, cryovolcanoes, likewise called ice volcanoes, discharge substances like water, alkali, or methane in fluid or gas form. These materials can exist in cool conditions like Ceres. Cryovolcanoes work by permitting water, blended in with salts, to ascend to the surface. When this pungent water meets the vacuum of space, it quickly dissipates, abandoning brilliant, reflective salt deposits. These deposits form the brilliant spots on Ceres' surface. The most popular of these spots is situated in a cavity known as a crater, specifically in a region considered Spot 5. This region has drawn a lot of attention due to its high reflectivity and strange haze seen by the Dawn spacecraft. The haze is believed to be caused by the sublimation of water, suggesting that cryovolcanic activity might still be progressing or may have happened recently. Ceres has a few other brilliant spots, each with its own properties. These spots are spread across the dwarf planet, suggesting that cryovolcanism might be a widespread process on Ceres. The presence of these brilliant spots highlights the remarkable nature of Ceres and raises significant questions about the potential for life in our nearby solar system. The dynamic and evolving nature of Ceres challenges prior thoughts that it was a geologically dormant world. As Dawn provided more detailed pictures of Ceres, more surface features began to emerge. Ceres' external surface is covered in craters, each marking a part of the planet's history. Some craters are shallow and worn out, showing an old surface that has been hit by many impacts over billions of years. Others are better preserved, with sharp edges and deep basins, indicating recent impacts. Curiously, there are fewer craters on Ceres than expected, which could mean that geological processes are renewing the planet, erasing older impacts. One theory is that Ceres' icy surface allows for cryovolcanic resurfacing, where subsurface materials rise and cover older features. This ongoing activity suggests that Ceres is not a still world, but one that has been, and may still be, changing. Extra evidence of surface deformation on Ceres comes from cracks, ridges, and faults, showing that its crust has been under pressure. Some of the cracks appear to be relatively young, possibly only a few 100 million years old. These features suggest that Ceres has experienced internal heating, perhaps from radioactive decay or tectonic interactions with neighboring bodies. These signs of brilliant spots, craters, and surface deformation indicate that Ceres has undergone a complex history of geological processes, including the possibility of past or ongoing cryovolcanism. These discoveries are crucial for understanding Ceres, as well as expanding our knowledge of planetary evolution and the potential for life beyond Earth. Might Ceres' frozen surface and subsurface water hold the key to extraterrestrial life? While the evidence isn't yet clear, it is evident that Ceres is a world full of surprises, with secrets still waiting to be uncovered. In all, the brilliant spots on Ceres offer an intriguing look into the complex and changing nature of this dwarf planet. With its potential for cryovolcanic activity, subsurface water, and ongoing geological resurfacing, Ceres is much more than a frozen remnant of the early solar system, a dynamic world that challenges our assumptions and opens new doors for exploration. As the Dawn spacecraft continues to send back data, it may yet reveal more secrets hidden beneath Ceres' cold surface. The journey to uncover the mysteries of Ceres is far from over. The Dawn spacecraft may have completed its mission, but its discoveries will continue to shape how we understand the solar system and the possibilities for life on distant worlds. As the Dawn mission concluded its primary stage, it left behind a legacy of remarkable data that will fuel scientific inquiry for years to come. The spacecraft's revelations on Ceres, especially the fascinating bright spots and evidence of geological activity, have reshaped how we understand the planetary system's minor planets. But what lies ahead for future missions exploring similar icy bodies? Mainstream scientists are eager to build on the insights gained from Dawn's investigation of Ceres. The possibility of subsurface seas, or at least pockets of liquid water beneath Ceres' icy shell, has spurred new studies into how life could exist in such extreme conditions. Water is one of the key ingredients necessary for life as we know it, and the potential for liquid water beneath Ceres' surface opens up exciting possibilities. If microbial life could thrive in such cold conditions, it could provide us with a glimpse into how life could develop on other moons or planets with subsurface oceans, such as Jupiter's Europa or Saturn's Enceladus. The question of life beyond Earth is one that has captivated the minds of scientists, philosophers, and the general public for years. With the rising focus on astrobiology, the study of the potential for life elsewhere in the universe, the data gathered from missions like Dawn helps refine our search for extraterrestrial life. Ceres, with its combination of rock, ice, and salt, could provide essential insights into understanding how life could arise in different parts of the universe, even in places once thought inhospitable. As we look forward to future missions to Ceres, alongside studies of other icy bodies in the solar system, we will build on the foundation laid by Dawn. While the spacecraft has completed its mission, its impact will continue through the ongoing analysis of the data it returned. Soon, new technologies might offer even clearer images of Ceres, and future spacecraft could land on or orbit similar worlds to collect samples and conduct further research. Ceres is far from an isolated case in the search for habitable conditions. The growing interest in moons like Europa, Enceladus, and even Pluto's Charon shows that there are many other places in the solar system with conditions that might support life, or at least the building blocks for it. The lessons learned from studying Ceres could provide invaluable data to help scientists determine the most promising candidates for exploration and study in the future. Beyond the search for life, the insights gained from studying bodies like Ceres can also help us understand the formation and evolution of our solar system. Ceres, as a remnant from the early solar system, provides a snapshot of the conditions and processes that shaped the planets and their moons. Understanding the processes that led to Ceres' unique features, its icy surface, salt deposits, and potential for cryovolcanism, helps piece together the larger story of the solar system's history. This information could reveal clues about the material composition of the early solar system, the role of water in planetary formation, and the development of other planetary bodies. With new technologies and continued interest in space exploration, we are just beginning to uncover the secrets of icy bodies like Ceres. As we probe further into these fascinating worlds, the questions about their potential for supporting life and their role in the history of the solar system will continue to inspire scientific inquiry and discovery. Ceres may have started as a distant, obscure dwarf planet in the asteroid belt, but thanks to NASA's Dawn mission, it is now a world of profound scientific importance. The bright spots on its surface are just the beginning of what promises to be a new chapter in our exploration of the universe. As we continue to study this captivating dwarf planet, who knows what new discoveries lie ahead? The journey to uncover the mysteries of Ceres, and the many other worlds like it, has only just begun.